Imagine writing like 10,000 lines of incredibly complex interconnected software code while you sleep. And then you wake up, stare at your screen, and realize you don't understand a single line of your own creation.
Right, it's just total gibberish to you.
Exactly. You try to debug it, but the logic is entirely alien. The application compiles, it actually runs, but you have no idea how or why.
So, welcome to the reality of AI-assisted coding in 2026.
Yeah, it's wild. The tech industry has been blasting this, utopian message that coding is now this fully automated, frictionless dream.
But when you actually boot up these products, you feel the instability. I mean, we feel it in our bones when we use the software. Apps are crashing in weird ways, massive platforms are rolling back features, and the whole structural integrity of the digital world just feels incredibly brittle right now.
We are definitely experiencing this profound disconnect between the venture capital marketing brochures and the actual physical reality of maintaining software. Like, we've achieved unprecedented velocity in code generation, sure.
But we're simultaneously watching the foundational architecture of our systems degrade. It's a very, very dangerous phase of technological development.
Okay, let's unpack this. Because we need to figure out what happens when the tools we use to build the digital world start, well, modifying themselves. Today, we're taking a deep dive into the source material surrounding this chaotic frontier of self-modifying software.
It's a fascinating topic.
It really is. And our core source today is a highly detailed transcript from a recent dispatch by the Pragmatic Engineer. It features this incredibly candid conversation between two veteran Austrian developers.
Yeah, Mario Znur and Armin Rohner.
Right. Mario created Pi, which is one of the most influential minimalist AI coding agents of the year. And Armin is the creator of the massively popular Flask framework, and he's now dealing with the fallout of these agents out in the wild.
And what makes this source material so compelling is that, neither of these guys are AI hype men.
Not at all.
They are deeply pragmatic. This isn't theoretical research happening in some clean room in Silicon Valley. It's a raw look at human psychology, automation bias, and the structural chaos that just erupts when you try to strip all the friction out of complex systems.
So to really understand the sheer scale of the pushback against that whole Silicon Valley hype, we have to look at where Mario actually comes from. Because the guy who built the most reliable AI agent didn't, incubate in some billion-dollar lab.
No, he grew up in Austria in the 1990s in an environment he literally describes as working class poor.
Right, and his entry into computing was incredibly hard won. He wasn't just gifted a machine. He had to walk to his uncle's house every other day just to play games on an old Amiga 500.
Yeah, and when he finally wanted his own computer, his parents just didn't have the disposable income. And so they made a deal with him. His father started doing what's called Schwarzarbeiten in Europe.
Which is basically unreported, off-the-books manual labor, right?
Exactly. Fixing
Yeah.
cars in driveways, working late nights on construction sites. He was literally trading physical sweat to save up cash for this kid's computer.
That detail really stuck out to me. They finally take him to a shop in a nearby city and buy this Intel 486DX 40 millihertz PC.
Okay.
And because he had to watch his family trade physical labor for this machine, he didn't just play games on it.
Right. He pushed it to its limits.
He really did. He dove into graphics programming, which in the 90s meant you were fighting for every single byte of memory. And that discipline carries him into university and eventually into applied machine learning long before deep learning was a buzzword.
He was taking raw, messy research and forcing it to work in industrial applications. And that background gives him a very specific lens on software.
Yeah.
He views computers as tools that require discipline to master, not,
Yeah.
Magic boxes that do the thinking for you.
Yeah.
So fast forward to early 2025, Mario was actually an enthusiastic user of a cloud-based AI tool called Claude Code.
Oh, right. Because he was fascinated by their implementation of agentic search. Let's actually break down how agentic search functions mechanically for you listening, because it's a huge shift. Before this, you were mostly chatting with an AI in a browser window. You paste code in, it pastes code back.
Right, it's very static.
But agentic search gave the model read and write access to traverse a local file system. It could navigate directories, read multiple files at the same time, map out dependencies, and actually execute terminal commands to find what it needed.
It was proactive,
Yeah.
instead of just reactive. And Mario found it deeply integrated with his workflow. But then the velocity of the startup building Claude Code became, well, its own worst enemy.
How so?
The development team started dogfooding.
Using their own tool to build the tool.
Exactly. Using Claude Code to write the next version of Claude Code, their iteration speed went through the roof. But suddenly, Mario noticed the tool behaving erratically, like the foundations were shifting beneath him.
Wait, if the tool is getting smarter and updating itself automatically in the cloud, why is that a problem? I mean, shouldn't a developer want a tool that improves every single day without having to install updates?
Not if those updates break your established logic.
Hmm.
Like, imagine you're building a complex physical bridge, right? And every morning you wake up, the manufacturer has slightly altered the calibration of your measuring tape.
Oh, wow. Yeah, that would be a nightmare.
It might be a mathematically smarter measuring tape, but your bridge is going to collapse. Mario realized that the developers were silently injecting new system reminders and tweaking foundational behaviors behind the scenes.
Just to optimize for their own internal metrics. And Mario didn't just suspect this, right? He actually proved it.
He did. He reverse engineered the obfuscated JavaScript running in his local environment.
That's intense.
Yeah, he dug through the minified code to expose the exact payloads they were using to change the context window behind his back. He proved that a cloud dependency is fundamentally at odds with engineering determinism.
I think he has a great quote about that in the transcript.
He does. He explicitly says, "I don't want my hammer to break at a different spot every day."
Right.
When an AI tool's underlying logic shifts dynamically based on some server-side update, it destroys your trust. You spend more time double-guessing the tool than writing the actual software.
So using a cloud-based AI agent is basically like having an assistant who randomly decides to change your entire filing system every night while you sleep. No wonder he built his own tool.
Exactly. So he ditches Claude Code. But he doesn't just go back to typing manually. He surveys the open source landscape around early 2025. He looks at tools like Aider and OpenCode. But he rejects them too.
Wait, why? If they are open source, they aren't changing behind his back, so what's the issue there?
The issue was architectural bloat. Let's look at OpenCode as the prime example. Mario absolutely hated that OpenCode ran a language server protocol or an LSP directly integrated with the agent's generation process.
Okay, let me make sure I understand the mechanics of this. An LSP is the background engine in a code editor that parses the text, right? It's what gives you the red squiggly lines when you miss a semicolon or call a function that doesn't exist.
Precisely. It's constantly evaluating the code for validity.
Right.
Now, think about how an LLM actually generates code. It outputs tokens sequentially. It streams them out one by one. So while it is mid-generation, say it has opened a function bracket but hasn't closed it yet, the code is, by definition, broken and invalid.
Ah, I see where this is going. So the LSP is running in the background, looking at this half-finished block of text and absolutely panicking.
Yes, it throws massive error diagnostics, and OpenCode was architected to feed those real-time error diagnostics straight back into the AI's context window while the AI was still typing.
Oh, it sounds awful.
It was constantly interrupting the model, feeding it hundreds of lines of error logs about code that wasn't even finished yet. It completely shattered the model's coherence.
So the AI gets confused.
Totally confused. It tries to pivot to fix an error that would have resolved itself in 3 more tokens, and it just ends up writing tangled garbage.
That sounds like actual torture. It's like trying to write a complex novel, and after every single word, an editor leans over your shoulder and screams that your sentence lacks a verb before you've even had a chance to finish the thought.
It is fundamentally hostile to the flow state, whether for a human or a machine. So Mario decides to build his own tool, which he names Pi. And his entire design philosophy for Pi is radical minimalism.
Right, he just strips everything out.
He strips out the LSP integration, he strips out all the bloated features. The core of Pi is nothing more than a thin abstraction layer over the raw LLM APIs, a very basic agent execution loop, and 4 fundamental tools: read, write, edit, and bash terminal access.
But if it's that stripped down, how does it compete with these massive venture-backed agents? I mean, the Silicon Valley stuff has billions behind it.
Through extensibility. The genius of Pi wasn't what Mario put into the core, it was the hook points he left exposed. He built it as a simple TypeScript module with extensive lifecycle hooks.
Meaning you can intercept the agent at any point in its loop, like before it sends a prompt or after it reads a file, you can inject your own logic?
Exactly. And because the architecture is so transparent and the tool itself is an AI agent, this bizarre and beautiful feedback loop emerges. The users don't have to sit down and spend 3 days writing complex TypeScript to build a new feature.
Right, they just use the AI.
Yes. They boot up Pi, tell it what they want, and ask Pi to write the code to modify its own source code.
The software literally writes itself. The source material has a wild example of this with Armin, right? Armin was working with Pi and decided he really wanted a plan mode, like a mode where the agent writes out a step-by-step architectural plan before it executes any code.
Yeah, and Mario refused to build it. He firmly believes plan modes are a total waste of compute.
So Armin just asked Pi to build it for him.
He did. He used the hook points. In fact, Armin generated 5 entirely different, fully functional implementations of a plan mode using Pi. He tested them all, evaluated their performance, and eventually realized that Mario was entirely correct.
Oh, that's hilarious.
Yeah, the plan modes were completely useless and just wasted tokens. But the critical takeaway isn't that the feature failed. It's the speed at which the software molded itself to his intent.
Think about that for a second. Think about the software you use at work. Imagine if, instead of submitting a feature request to IT and waiting a year, you just told the software what you wanted and it rewrote its own source code on the fly to accommodate you.
It's a total paradigm shift in how we interact with utility software.
Yeah.
Other developers took Pi and completely overhauled the visual interface, adapting it to run specialized, non-technical workflows for data entry.
Wow.
Someone else hooked Pi into a full reinforcement learning environment, allowing the agent to execute code, measure the performance reward, and adjust its own behavior dynamically.
It's incredible. And the transcript mentions that this exact capability is why Pi quietly became the foundational engine beneath OpenClaw.
Yes, OpenClaw.
OpenClaw is this massively popular personal AI assistant built by a developer named Peter Steinberger. But OpenClaw doesn't handle the raw execution itself. It delegates the heavy lifting to Pi's minimalist core.
And this required Pi to adapt again. Peter needed OpenClaw to process visual data, so he pushed for screenshot ingestion. But more importantly, the source mentions Peter was practically begging Mario, crying in the chat, as Mario put it, for a specific feature called compaction.
Okay, compaction. What is that exactly? How does that work mechanically?
So compaction solves a critical limitation of agentic memory. As an agent works, the transcript of its actions, every file it reads, every command it runs, grows.
Right, the history gets longer.
And eventually that transcript hits the limit of the AI's context window. Compaction is a mechanism that forcefully squashes that history. It takes thousands of lines of operational history and compresses it into a dense summary state.
So it discards the raw logs but retains the meaning.
Exactly. It retains the semantic meaning, allowing the agent to keep operating without amnesia.
So Mario writes the compaction feature, Pi gets stronger, and OpenClaw scales massively. It sounds like an absolute triumph of engineering. But this is exactly where the transcript takes a very dark turn.
It really does.
Because giving machines this level of autonomy, allowing them to rapidly generate and execute code, creates a massive blind spot. And it revolves around a concept I found deeply fascinating, which is the loss of human pain.
This is the philosophical core of their entire discussion.
Mm-hmm.
We have this tendency to anthropomorphize AI agents. We call them interns or junior developers, but they completely lack the biological feedback mechanisms that shape human learning.
Right.
Specifically, agents do not feel the pain of maintenance.
Now, let me push back on that for a second. If an agent writes terrible code, the code fails the automated test suite, right?
Oh.
The system throws an error, the pipeline turns red, and the code's rejected. Doesn't the system naturally enforce quality even without a human feeling pain?
You are assuming the agent behaves like a human who wants to fix the root cause. When a human writes a convoluted, tangled mess of code, they eventually have to debug it at 3:0 a.m.
Yeah, we've all been there.
They feel the stress, the fatigue, the literal physical pain of technical debt. This creates a psychological aversion. A senior engineer becomes highly effective, specifically because they have accumulated battle scars.
They know what happens when things get too complex.
Exactly. They learn to say no to bloated feature requests because they know the long-term suffering that complexity brings. They enforce simplicity as a survival mechanism.
And the agent has no survival mechanism.
And then, when the pipeline turns red, the agent doesn't feel stress, it just sees an error string. And because it operates at light speed, instead of stepping back and refactoring the architecture to be simpler, it simply writes a hyper-complex workaround to force the tests to pass.
It just slaps a Band-Aid on it.
A very complex Band-Aid. It patches the bad logic with more bad logic. It says yes to every prompt, infinitely layering complexity because it never has to maintain the mess it creates.
Armin gives a brilliant non-AI example in the transcript to illustrate what happens when systems get too complex. He talks about his time working on the matchmaking system for the Halo Master Chief Collection on the Xbox One.
Oh, this is a great story.
He describes tracking down a matchmaking bug that turned out to be an emergent state machine.
This is a vital mechanical concept to understand. The human developers had patched and patched the matchmaking logic until it relied on 16 different Boolean variables, true or false flags, interacting with each other simultaneously.
Okay, 16 booleans doesn't sound that crazy on the surface.
Mathematically, it is terrifying. 2 to the power of 16 means there are 65,536 distinct possible states that matchmaking system could be in at any given millisecond.
Oh, wow.
No human mind can track 65,000 interacting states. It becomes an emergent system. Unpredictable behaviors arise that no programmer explicitly wrote. And Armin draws a direct, chilling parallel between that human-created disaster and the code that AI agents are currently generating at scale.
How so? Like, what's the connection?
When an AI encounters an unexpected edge case, its default behavior isn't to fail gracefully. Failing cleanly is a hallmark of good engineering. Instead, the AI tries to catch the error, load a default configuration, and silently proceed.
It just powers through.
It writes error handling loops that obscure the failure. Suddenly, your application is tangled in thousands of new, invisible failure states. The agent is constructing 16 Boolean nightmares every few minutes.
It's masking the structural damage, and this creates a severe psychological trap for the human overseeing the code, which the transcript calls automation bias.
Automation bias is the human mind's tendency to defer to a machine's judgment, especially when the machine has previously demonstrated competence.
Right.
An AI agent will often generate an incredibly elegant, brilliant piece of code early in a session. The human reviewer sees this and experiences a sense of relief. They lean back, they think, well, this model is a genius, I don't need to scrutinize every single character.
I've felt that exact feeling. You review the first 3 functions, they look absolutely flawless, so you just hit approve on the rest of the pull request. You just trust it.
And that is the exact moment the trap closes. Because 2 minutes later, in that very same generation window, the model might hallucinate and spit out the most unhinged, dangerous garbage imaginable.
But the human has mentally clocked out.
Exactly. The friction of review has been removed by the illusion of competence. So the garbage gets merged straight into the production code base.
Here's where it gets really interesting for you listening. If the machine doesn't feel pain, does the pain just get transferred to the human who eventually has to untangle this mess? Are we just deferring our suffering?
It is a deferral of suffering on a mass scale. And this dynamic becomes catastrophically obvious when companies attempt to scale this process up. We aren't just talking about one developer using Pi anymore. We are talking about the enterprise obsession with the dark factory.
The dark factory. Yeah, Mario actually wrote a scathing blog post about this recently titled, "We all need to slow the F down."
He was very blunt.
He was. The dark factory is this highly promoted concept where you don't even need developers anymore. You write a product specification, you hand it over to a swarm of 100 autonomous AI agents, you give them distinct roles like, you're the coding agent, you're the QA testing agent, you're the mayor overseeing the project, and you just let them collaborate in a dark environment without any human oversight.
And Mario systematically dismantles the viability of the dark factory using brutal, undeniable math. We know that an AI agent can write roughly 10 times the amount of code a human can in a single day.
Right.
However, it also introduces 5 to 10 times more logical errors and structural bugs. Now, a senior human engineer working diligently can meaningfully review and comprehend about 1,500 lines of code per day.
So if your swarm of agents is suddenly churning out 10,000 or 15,000 lines of complex interconnected code every 24 hours, human review isn't just difficult, it is mathematically impossible. You are physically incapable of reading the output of your own automated factory.
And because you can't read it, the bloat compounds. And this leads to what Mario identifies as the context window paradox. This is a severe limitation in current AI architecture.
Tell me more about that.
As of 2026, a high-end model might have a context window of about 200,000 tokens. That is the absolute maximum amount of text code, instructions, and history that the AI can hold in its active memory at one time.
Which is roughly, what, 50 to 60,000 lines of code?
Approximately, yeah, depending on the density. Now, what happens when an agent writes bloated, overly complex code to solve simple problems? The overall size of the code base inflates rapidly.
Right.
Within a few days in a dark factory, the code base grows so massively that the agent can no longer fit the relevant files into its own context window.
Oh, wow. It literally pushes its own operational memory out of its brain.
Exactly. To fix a bug in file A, it needs to understand file B. But there isn't enough room in its memory for both. It becomes functionally blind to the architecture it just created. As Mario states, the complexity they add is their own worst enemy.
But wait, Why is the baseline behavior to write bloated, complex code? If the models are so advanced, why aren't they naturally writing elegant, concise logic?
It all traces back to their foundational training data. How do these models learn to code? They scraped the entire internet. They ingested millions of open source GitHub repositories.
And the internet is entirely composed of pristine, flawless code, right?
Quite the opposite. The internet is a graveyard of abandoned projects, sloppy college assignments, and heavily bloated corporate frameworks. Critically, it is full of cargo cult programming.
I've heard that term, cargo culting. Explain the mechanics of that.
The term comes from a historical phenomenon where islanders would build mock airplanes out of wood, hoping to attract real supply planes like they saw during World War II. They replicated the form without understanding the underlying mechanics.
So that makes sense.
In software, cargo cult programming is when a developer copies a block of code from Stack Overflow or implements a massive design pattern simply because they saw it used elsewhere without having any idea why it works or if it's necessary for their specific problem.
They're just mimicking the shape of coding.
Yes. And the AI models have ingested all of this mimicry. An LLM operates by predicting the most statistically probable next token. It converges on the mean of its training data. And the mean of all human code on the internet is, frankly, bloated, cargo-culted garbage.
Wow.
We are unleashing autonomous swarms that operate at light speed, utilizing the most mediocre architectural patterns ever devised by humanity.
The transcript brings up an incredibly sharp analogy here regarding the Swedish education system. A few years ago, there was this massive, uncritical push to throw iPads and laptops into every classroom in Sweden. The tech industry declared, "Education is solved, we digitized it." But they didn't study the actual cognitive impact on the students.
And the results were disastrous. Reading comprehension dropped. Deep focus was shattered. And now, the Swedish government is actively spending millions to roll those tablets back out of the classrooms and physically replace them with printed textbooks because the technological solution actively worsened the core metric.
And Mario argues we are doing the exact same thing to software engineering. We are throwing swarms of agents at code bases, watching the lines of code metric go up and cheering, but we are entirely ignoring the long-term structural degradation of the digital infrastructure we all rely on.
Which brings us to the core cultural sickness driving this degradation. If the math of the dark factory inevitably leads to bloated, unmaintainable code, why are companies still pouring billions into accelerating it?
That is the million-dollar question.
Because the current tech culture has declared war on the concept of friction.
Armin tells a story in the transcript that perfectly encapsulates this. He mentions a recent massive security incident at a major tech company, and he points out the bitter irony that this specific company's literal public-facing tagline was, "Ship without friction."
That tagline is treated as a gospel virtue in 2026. But it demonstrates a fundamental misunderstanding of systems engineering. Before the AI boom, engineering teams did not try to eliminate friction. They deliberately and painstakingly engineered friction into their pipelines.
Right. If you were working on a Tier 1 critical service, let's say the database that handles user authentication or payment processing, you couldn't just push a change live because you felt like it. There were deliberate speed bumps.
Absolutely.
You might need mandatory code reviews from 2 separate senior engineers. If you wanted to alter a database schema, you might need a director's explicit written approval.
That bureaucracy was not a failure of agility. It was a psychological filter. When a developer knows they have to explain their code to 2 senior peers and defend it to a director, they pause. They ask themselves, is this minor configuration tweak really worth the massive effort of navigating the approval process?
It naturally filters out bad, impulsive, or unnecessary ideas. It's like removing the speed bumps in a school zone because you want the traffic to flow faster, and then acting surprised when accidents go up. Friction is there to protect the environment.
Exactly. Speed without friction in an isolated environment might be fine. But a code base is a complex, interconnected system. Speed without friction in a complex system equals catastrophic crashes. And the problem now is that the people removing the friction aren't even engineers who understand the risks.
This was the wildest part of the transcript for me. Armin talks about how non-engineers, product managers, marketing associates, sales reps are now using AI agents to bypass the engineering departments entirely.
It's happening everywhere.
They use an agent to spin up a feature, and because the organizational friction has been stripped away in the name of velocity, they're pushing pull requests straight into live production code bases.
Armin specifically highlights a scenario where a sales team literally built and merged an entirely fake feature. They wanted a shiny button for a specific client demo, so they had an agent write the UI code and merge it into the main branch.
And nobody caught it.
No one noticed until it broke something else, because the agents had bypassed all the traditional friction points.
It's terrifying, and this lack of friction isn't just degrading private corporate code bases. It is spilling out into the wild and actively attacking the absolute foundation of the modern internet, which is open source software.
The transcript details a literal siege currently taking place on open source repositories. Projects like Linux, Flask, and React are built on the careful, deliberate coordination of human collaboration. But today, the maintainers of these projects are drowning in an ocean of AI-generated pull requests and issues.
Mario and Armin refer to these automated PRs as clankers, which is a brilliant reference to the mindless battle droids from the Star Wars Clone Wars. Just endless, relentless waves of mechanical noise storming the gates of open source.
And the mechanism of the attack is often entirely unintentional, which makes it even harder to stop. Remember earlier when we discussed how Mario's minimalist Pi agent is the hidden engine powering the massive OpenClaw assistant?
Yes, Peter Steinberger's app.
Because the dependency chain is hidden, when an average user encounters a bug while using OpenClaw, their local AI agent attempts to be helpful.
Oh, no.
The agent traces the error stack, incorrectly determines that the root cause is a flaw in Mario's Pi repository on GitHub, and autonomously navigates to Mario's public repo. It then automatically generates a complex patch and submits a pull request, or opens an incredibly detailed, hallucinated issue report.
And the human user doesn't even know their agent just did this.
They have no idea.
So Mario's receiving thousands of issues and PRs that have zero human intentionality behind them. He's basically being DDoSed by helpful robots.
Armin actually tried to step in and help Mario manage the flood. He went into Mario's repository to manually review and clear out the backlog of pull requests, but Armin surrendered almost immediately.
Why? Was it just too much?
He realized he was fighting an unwinnable war of attrition. Armin would spend an hour carefully reverse engineering an AI patch, fixing the complex logic and merging it cleanly. 5 minutes later, another clanker would encounter the same perceived bug, autonomously submit a new PR that completely overwrote and reverted Armin's human fixes, and the cycle would begin again.
You cannot outwork a machine that never sleeps and costs fractions of a cent per request. So how do you defend a public project against an army of clankers? Do you just lock the repository and kill open source entirely?
Mario developed a genuinely ingenious defense mechanism that reintroduces friction through an automated Turing test. He wrote a custom GitHub action, a script that runs automatically on the server, that instantly and ruthlessly closes every single new pull request submitted by an unrecognized user.
Wait, it just auto-rejects everyone.
Yes, but with a catch. The script leaves a very polite, automated comment on the closed PR. It says, "Thank you for contributing. We are currently overwhelmed with automated submissions. If you are a human and want this merged, please open a separate issue written in a human voice, no longer than a single screen of text explaining the intent of your code."
Oh, that is brilliant. If the user is a human, they read the comment, realize what's happening, write a quick summary, and Mario manually adds their username to a safe list. From then on, their PRs bypass the auto-close script.
Exactly. But the crucial mechanical flaw of the clankers is that they are entirely fire and forget. The AI agents submit the code and terminate the session. They do not stick around to read the automated comment.
Right.
They don't process the rejection. Therefore, the thousands of clankers get permanently, silently filtered out into the void, completely ignored.
That's a beautiful solution. But, it raises a deeply melancholic philosophical point about the state of software. Open source used to be defined by human energy. It was a massive congregation of brilliant minds piling onto incredibly hard problems because they cared about the craft.
Yeah, like Linux.
Exactly. Now, that precious human signal is being entirely drowned out by cheap, subsidized compute tokens generating infinite noise.
It is a tragedy of the digital commons. However, Mario remains fundamentally optimistic. He argues that the core projects, the ones maintained by real, dedicated communities, will survive this era of noise. We simply have to invent new, creative bottlenecks, like his auto-close script, to defend the signal.
So while the open source maintainers are literally building walls to keep the bots out, there is a highly technical, almost religious civil war happening among the developers who actually build bots. And this debate is entirely about how an AI agent should be allowed to communicate with a computer's operating system.
This is the great technical divide of 2026, the Model Context Protocol, known as MCP, versus the Command Line Interface, or CLI.
Let me see if I can set the stage for this. You have two totally different philosophies on how an AI should retrieve data. The enterprise world, the massive Fortune 500 companies, are absolutely obsessed with MCP.
Correct. MCP was designed as a standardized, highly controlled bridge. Large companies love it because it enforces strict authentication, security boundaries, and compliance tracking.
Which makes sense for them.
Right. If you want an AI agent to read a secure corporate OneDrive folder or query an internal HR database, you don't just let it roam free, you build an MCP server. The MCP server acts as a tightly regulated API. The AI asks the MCP server for data, the server verifies permissions, and then hands the data back.
That sounds incredibly safe and logical for a big bank. So why do developers like Mario and Armin absolutely despise MCP for complex coding tasks?
Because of how MCP handles the data payload mechanically. When an AI uses an MCP tool to fetch a file, the MCP server dumps the entirety of that raw data directly into the AI's context window.
Wait, all of it? If it asks for a massive database log, the MCP just shoves the whole log into the LLM's short-term memory.
Yes. The AI is then forced to perform all the data transformation, filtering, and logic internally inside its own neural network. And as we established with the dark factory, context windows are fragile.
Right, they blow out easily.
If you connect an agent to 30 or 40 different MCP tools, the agent is constantly flooded with massive, unfiltered JSON payloads. Its memory gets obliterated. Furthermore, MCP tools are rigid. They are not composable. An AI cannot easily chain the output of an HR database MCP directly into a code compilation MCP without funneling all the raw data through its own brain first.
Okay, let me try an analogy here. Using MCP is like forcing a master chef to memorize the barcode and nutritional information of every single ingredient in a grocery store before they are allowed to start cooking. It's overwhelming their cognitive load with raw data.
That analogy captures the cognitive overload, but it misses the mechanical restriction. A better refinement, MCP is like telling the chef they cannot use any kitchen tools unless the manufacturer explicitly built a custom adapter for their specific hands.
Oh, I see.
If they want to chop a carrot, they have to request a pre-chopped carrot from a centralized supplier.
Ah, okay. It restricts their direct agency. Which brings us to the hacker approach, CLI, command line interface. Tinkerer tools like Mario's Pi completely ignore MCP.
They do. Instead of relying on pre-built restricted APIs, tools like Pi give the AI raw, unfettered access to the computer's bash terminal.
Which is how humans interact with it.
Exactly. If the AI wants data, it doesn't ask an API. It physically writes a bash script, executes it on the host machine, and, this is the critical difference, the AI only looks at the output of the script, not the raw data itself.
Armin shares a story in the transcript that perfectly illustrates why this is so powerful. He was watching an agent try to analyze a 20-megabyte server log file. The agent executes a basic bash command to open the file. It instantly realizes, based on the file size, that ingesting 20 megabytes will completely blow out its context window and ruin its memory.
So how does the agent adapt? It stops. It pivots. It autonomously decides to write a grep command. grep is a standard, decades-old Unix utility used for searching plain text data sets for lines that match a regular expression.
Right.
The agent writes a grep command to search the massive file specifically for the word error, executes it, and the terminal spits back only the 3 specific lines of code that matter.
The agent used the computer's native tools to filter the data before it ever entered its own brain.
Exactly. That is the creative problem-solving magic of CLI. The agent is composable. It can chain tools together natively. It behaves like a real veteran systems administrator. MCP removes that creative problem-solving by forcing all the raw data through the AI's fragile context window.
Okay, let's unpack this. So the enterprise world is adopting a standard that is technically safer, highly compliant, but actually makes the AI dumber and restricts its problem-solving abilities. Meanwhile, the solo developers, the hackers, are building these minimalist CLI tools that let the AI run wild, invent its own bash scripts, and solve problems organically.
It creates a bifurcated future for software development. The speed of innovation in the CLI hacker space is vastly outpacing the heavily regulated MCP-shackled enterprise environments.
Knowing all of this, the technical divide, the siege of the clankers, the mathematical impossibility of the dark factory, where does this actually leave the industry? In the source material, Mario and Armin try to look ahead to 2027.
But Armin astutely points out that predicting the future of AI is nearly impossible. because time in this industry operates in dog years.
Dog years, yeah.
One calendar year of AI development feels like 7 years of traditional technological progress.
Yeah.
The landscape shifts too violently to make accurate long-term bets.
However, Armin does predict a massive geopolitical wake-up call, particularly focusing on his home continent of Europe. He notes that entire European software companies, massive engineering organizations, are currently becoming completely structurally dependent on just 2 or 3 massive US-based AI labs, primarily OpenAI and Anthropic.
It is an unprecedented dependency risk. Armin admits that engineering teams are privately confessing to him that they have allowed their code bases to become so complex, so saturated with AI-generated logic, that they physically can no longer maintain their own software without the machine.
That's a scary thought.
If those U.S. labs suddenly triple their API prices, or if an international regulatory dispute cuts off access to the models, these European companies are functional paralyzed. They've outsourced their cognitive foundation.
And this leads to a deeply personal, almost somber admission from Armin himself. A guy who built one of the most famous Python frameworks in the world admits to experiencing what he calls agentic regret.
Agentic regret.
Yeah.
He acknowledges falling into the very trap he critiques. He admits there were days where he was tired and he just let the machine dictate the architecture.
He just gave up control.
He let the agent implement a feature in a convoluted way that he never would have written himself, simply because it was faster than fighting the model.
It's the hangover after the hype cycle. You wake up, you look at the complex, tangled code base you supposedly built yesterday, and you realize you have entirely lost your foundational understanding of your own project. You have a stranger in a house you own.
Which is why their strategy for maintaining sanity in 2026 is so crucial. How do these two veteran developers survive this hurricane of complexity? They intentionally disconnect.
They tune it out. They explicitly stop reading the endless panicked Twitter threads about the inevitability of the dark factory. They ignore the San Francisco hype cycle. They talk about the absolute necessity of literally going outside. Mario goes ice skating. Armin spends time with his kids. They step away from the terminal.
It is a vital defense mechanism against the anxiety of exponential change. They recognize that human limits, biology, attention, fatigue, are not bugs to be optimized away. They are the grounding forces of reality.
And that is such an important reminder for anyone listening who feels overwhelmed by the pace of AI. Whenever a deeply transformative technology arrives, society enters a honeymoon phase. We put the blinders on. We only focus on the magic, the velocity, the lines of code generated per second.
Right, but the current chaos is just a phase.
Exactly. The chaos we've discussed today, the clankers destroying pull request queues, the massive context windows collapsing under their own bloat, the 16 Boolean state machines, this is just the chaotic peak of the hype cycle.
It is a system out of equilibrium. It has to self-correct because the current trajectory of exponential bug generation and infinite complexity simply isn't sustainable. The laws of computing and the limits of human cognition will eventually enforce a correction.
The systems will physically break until we are forced to reintroduce the friction we so eagerly stripped away. So let's briefly recap this journey. We started with Mario Zunner, a developer who learned the value of hard work fixing cars in Austria, eventually building Pi, a minimalist, highly extensible, self-modifying hammer that refused to change its underlying logic behind his back.
Yeah, a true pragmatic approach.
Then we explored the terrifying math of the dark factory, where autonomous agents spin out millions of lines of unreadable, cargo-culted garbage because they don't feel the biological pain of technical debt. We watched the endless waves of clankers lay siege to open source, forcing humans to build automated Turing tests just to survive.
It's been quite the ride.
We explored the deep technical rift between rigid enterprise MCP protocols and the creative freedom of the CLI. And ultimately, we realized that friction, the speed bumps, the manual code reviews, the slow, agonizing bureaucracy of engineering is actually the protective barrier that keeps our digital infrastructure from collapsing.
We arrived at the realization that elegant, reliable software is not just a product of logic. It requires a human element. It requires the physical pain of maintenance to force simplicity and legibility.
But the source material leaves us with an opening to consider a deeply unsettling consequence of this trajectory.
We've spent this entire deep dive establishing that human friction must remain the bottleneck to ensure quality. Humans must be able to read and understand the code. But if companies continue to push the dark factory and code bases become entirely alien and incomprehensible to the human mind, what happens to the pipeline of human knowledge?
That's the real danger.
If a junior developer entering the industry today can no longer learn by reading the codebase, because the code is an unreadable 65,000 state AI hallucination, how do they ever become a CU developer? If the machine becomes the only entity capable of reading our infrastructure, does the human software engineer effectively go extinct in a single generation, not because they were replaced, but because they can no longer learn the language?
That is a terrifying thought. If we can't read the history, we can't shape the future. We are going to have to decide very soon if velocity is worth sacrificing our own literacy. Thank you so much for joining us on this deep dive into the source material. We hope exploring the mechanisms behind the hype gave you a clearer view of the landscape. Stay curious, demand friction in your systems, and seriously, go outside and step away from the screen for a bit. We'll catch you next time.